In this section, we're going to make some big changes and server render our application. Among the different changes, we'll move from Create React App to a custom Webpack configuration. We're going to ditch our code splitting setup and in the end replace our data fetching approach. In this video, we'll focus on setting up everything that's necessary to render our React app from the server side. This means setting up the necessary things to make React work in the server. The basic concepts behind server rendering are the following. First, create a server bundle. Next, render the app to a string, and then serve the HTML including the pre-built app. And finally, share the Redux store state between server and client. Let's check some code examples. Okay, so let's check out our server. We created an Express app, imported our Webpack configuration, and we're using Webpack to build a server. We'll use a custom server render middleware to serve our application. Let's open the server render file. In this file, we import React-Thunk server version, our app component, and our store. To get our app component, we use the getApp function, and to get our store, we use the getStore function. We'll see what's going on inside these files later. The purpose of server render middleware is to send an HTML file that contains the content of our application, right from the initial load. For this, we use React-Thunk method render_to_string. Because we're using style components, I also use the collectStyles method to extract our style sheets. Finally, we attach the Redux state to the window using a script tag and the store_getState method. We obtain the store from the getStore function. This function expects a preloaded state as first argument, which is undefined because the store has just been created, and as a second, the current app's location path name. For this, we're using rec or request.path. Inside the getApp file, we have a function that receives an instance of the Redux store and returns our app wrapped with the React Redux provider. Inside the getStore file, we have a function that receives the preloaded state and the initial entries, which is an array including the current path name, also known as the location path name, and it contains our original store configuration. One thing to have into account is that now we're creating our router with the getLocation function. This function receives the initial entries and returns everything we need to set it up. After creating a store using the provided params, it returns a store instance. Inside our router file, we have our routes defined, and we now export a function that receives the initial entries and returns the result of connect routes. Another change we've made is that now we're importing the pages directly into the router. This defeats the previous code splitting approach, so why did we do this? Well, server-side rendering and code splitting don't play along very well. If you want to do this, you can achieve this by using the Redux First Router ecosystem, which includes React Universal Component and Webpack Flush Chunks libraries. In combination, they make possible code splitting and server-side rendering. However, the implementation is not trivial and in my opinion is a bit brittle. Another solution for this that I would recommend is to use Next.js framework. This framework handles both server-side rendering and code splitting and does a great job at it. We've covered everything needed to server render an application. Let's test it. As you can see, when we load the page, there's no blank flash. The styles and the markup load straight up from the server. If we navigate to the app, you'll notice that the panels are empty. This is because the web page is loading before the data can load. We'll address this issue later. Another thing you'll notice if we open the DevTools is that every time we change pages, a request to the server is made. For example, here and here. Both of these are requests. We'll tackle these two in the next videos.